All right, I think you are live now, so you can begin whenever you're ready.
Awesome. All right. Hello, everybody. Thank you for attending this workshop. My name is Tim, and what we're going to be doing is looking at Python object-oriented programming. So this is presented by me, Tim Ruscica. I am the founder of Tech with Tim Incorporated. If any of you know me, you probably know me as Tech with Tim. That's kind of the alias or the name I go by online. Moving on, I'm just going to give you guys a quick introduction about myself so you know who's about to teach you in this next hour, object-oriented programming, and then we'll move into kind of an agenda, and I'll talk about who this is for so you guys can make sure you're in the right place and this isn't going to go over your head. So first of all, I am 20 years old. I currently am studying computer science at the University of Ottawa. I also worked for Microsoft as a software engineer intern. I did that this summer. I'm going to be joining again next summer. To go back to the first point, I'm currently in third year of computer science and I'm wrapping up my first semester right now. Other than that, I am the founder of Tech with Tim Incorporated. Now, that is just my company, but that encompasses my YouTube channel, my website, and all the kind of stuff related to pretty much just my online presence. I also worked as a STEM program coordinator. I did this at a summer camp, and what I did there was built out a coding specialty designed to teach kids how to code in Python. So people between the ages of 9 and 15 attended the program, and then what I did was just teach them coding. It was pretty successful. I learned to code at 12 years old, interesting fact, and I've been teaching programming for about 5 years, which is kind of hard to believe because I'm only 20 years old, but I have been kind of in this teaching space and doing this stuff for actually a good amount of time. Other than that, the programming languages at the top of the screen are personally my favorite programming languages. So Go, TypeScript, JavaScript, Python, and recently Dart. And now we will move on. So now I'm just going to quickly talk about my YouTube channel. Some of you guys probably have seen this before, but that's why I was actually invited to speak here because of my online presence. So I have a YouTube channel called Tech with Tim. It has almost 500,000 subscribers. We're getting pretty close. And just to give you an idea of some of the stuff I do on that channel, I have some random thumbnails I plucked from the channel just to show you. So I do web development. I do a lot of Python tutorials. You can see an expert Python tutorial playlist here. I recently did a tutorial series on making a Flutter application that's using the Dart programming language. I've taught things like Golang, neural networks, machine learning with Python, introduction to JavaScript, Python as fast as possible, just a one-off video I did, and then things like exploring a real Microsoft code base and some other just general tips and advice videos for people that want to become software engineers or learn computer science and programming. All right, so that's kind of it for me. If you guys have any questions, leave them in the chat and I will try to respond to them. But with that said, we're going to get into object-oriented programming now. That is going to be referred to as OOP. So if you ever see me saying OOP or you see OOP, then that just means object-oriented programming. And random fun fact, if you put Python before this, then you can see what the acronym is. Someone pointed that out on one of my videos. I thought that was funny. All right, moving forward, what we'll cover in this tutorial, seminar, whatever you want to call it. So first of all, why would you use OOP, object-oriented programming? I'll show you some examples of object-oriented programming that you've already seen before if you've worked in Python, but probably just didn't know they were OOP. Then I'll get into some fundamental object-oriented programming concepts. We'll get into a comprehensive OOP example. I'll then show you some special object-oriented features in Python. These are meant to just kind of show you what's possible. Don't worry about fully understanding all of those things. And then we'll get into a Q&A. But as I said, if you guys have questions, just drop them in the chat. I will probably answer them pretty much right away after you ask them. All right, and lastly, recommended prerequisites. So just in case you're an absolute complete beginner, I want to be clear that you probably need to know some fundamental programming skills or have some fundamental programming knowledge to be able to follow along with this. Also, familiarity of Python syntax. I assume if you're watching this, you're probably familiar with that. But anyways, just make sure you know a little bit of Python. Otherwise, this will probably be hard to follow along with. And lastly, if you want to follow along, I would encourage you to type out some stuff and mess with stuff on your own. Then you, of course, will need Python installed and some code editor. Now, I'm just going to be using Sublime Text just for simple, easy stuff. You could also use something like VS Code. You can use the default Python interpreter. Whatever you want is totally fine. Okay, so I'm just going to get myself settled here for 1 second, and then I'll be right back, and I'm going to actually be sharing my screen. I'll be in a code editor, and then we'll go through all this stuff. But my Zoom window seems to have disappeared, and I'm trying to look for the chat window. So let's try to find this here. Okay. Sorry, guys. Just give me 1 second.
If it works easier, I can just unmute and tell you whenever a question comes in.
Yeah, that would probably work. I've totally lost the Zoom controls. Something's happened here. And I can't even see like anything on the screen. So of course, technical difficulties right when we start. Yeah, just bear with me for 1 second, guys. I think I need to sign in or something, and then it should hopefully work. Okay. So it's just all been moved up to here. So that's why. Okay, chat. There we go. Now I have the chat. Yeah, so you can share that in the chat. I just had to move that to the right place. And let me turn my camera back on. And okay, we should be good to go now. All right. Okay. Sorry about that delay, guys. Of course, technical difficulties right when I start the presentation. All right, but let's get started. I want to discuss Python object-oriented programming. And obviously, the first thing we need to do there is define what an object is. So Python is actually an object-oriented programming language. So pretty much everything in Python actually is an object. Now, I just want to get started with a really basic example to illustrate what I mean by object. So if we have a look at this variable, x equals 1. Now, anyone who's just maybe a beginner in Python or you don't know too much about this, you would just say, okay, x is a variable, it's equal to the value 1. But really, 1 is actually an object. Now, that seems weird, but 1 is an object of the class or of the type what? Of the type int, right? So when I say this is a variable, I say x is a variable equal to 1. What is 1? 1 is an int. Now, if we have a look at the variable y, we can see that this is a string, right? This is of type string. Now, just to prove to you that I'm not lying, I will quickly print out the type of these variables. So we'll print out the type of x and the type of y, and notice that we get class int and class string. Now, this leads me into kind of the, I don't know, formal, informal definition of an object. An object is simply an instance of a class. So when we look here, we can see that both int and string are a class. Now, these are default classes. These are built into the Python main library. And well, I don't need to explicitly define that one is an int. Python just knows that it is an int. And we can see that when we print out the type. Now, just to show you something else, if I do something like true and I do the type of that, you can probably guess what that's going to be, but we get class bool. Now, all of these values here, all of these variables are objects that are instances of these classes. So one is an object that is an instance of int. String is an object, which is an instance of string. And bool is, well, a boolean, which is an instance of bool. So pretty much what these classes do is they define the behavior. They're kind of like a blueprint for how these objects can interact with each other, what methods can be called on them, if we can add them together, the different operations that can be performed on them. Think of a class as kind of a set of rules or the blueprint for an object. So when I create an integer, well, I know that since this is of class int, I can add it to other numbers. I can subtract it. When I have a string, I know that I can use methods, say like .upper. So if I do something like y.upper, we know that this will work. And just in case you're not aware what that method does, that will take the string and just put it into completely uppercases like that. But why can I not do something like z.upper? How come when I do z.upper and I run my program, I get an error? Well, what does it say? Bool object has no attribute upper. What that is telling me is since bool is of, or since this object, sorry, is of class bool, it does not have this upper method defined on it, and therefore I cannot use it. So this is just all to show you that everything you interact with in Python is an object, and it is defined in its rules and kind of ways that it interacts with the program is defined by a class. Now, we don't see that class because these objects right here are just default Python data types, right? We just take them for granted. The fact that we have integers, the fact that we have strings, the fact that we have booleans, but really somewhere in the Python main library, there is a class defined, which is called int, string, bool, so on and so forth, that tells Python how these objects should interact, what methods we're allowed to use on them, and how we create these objects when we start. So hopefully that makes sense, but that is kind of to give you the, I don't know, baseline understanding of what an object is. It really is an instance of a class. And the type of an object is whatever class it is an instance of. And that tells us what we can do with that object. And that's just kind of laying the groundwork here so that all makes sense. Now let's have a look at a few other objects and just show you some cool things that you might not know. So if I make another variable x, and I make this equal to a list, this is not the traditional way that we make a new list, right? Usually you might do something like this to make a new list, but really both x and y are completely equivalent. In fact, let me print these out to you, and I'll show you why this is the case. So we have two empty lists. This right here is the class list. I've written the name of the class, which is list. Y is a class list, right? And then I've just put two parentheses like that. What this does is this constructs a new list. So this is what's known as, actually, I don't really know the official name to put this here, maybe like a class instantiation or something like that. But I am making a new instance of the list class when I write this line. And that's completely equivalent to what I do when I define these two brackets here. But Python just knows that these two brackets pretty much mean do this, write this list class thing. Now, just to show you something interesting, what happens if I go inside of this list class and I define, say, 1, 2, 3? Well, if I do that and we print this out, we see that we get a list that has the values, well, 1, 2, 3. This is a way that we can instantiate a list, right? Now, what happens if I go ahead and actually make this a string? Let's see what we get. Well, what does it do? It actually takes all of the different characters here and puts that into a list. So this just shows you that this is a list constructor. And this is another way that we can create objects, is using their actual class name and then the parentheses afterwards. A good example of this is something like set. You've probably seen this. This is probably how you create a set in Python. By default, what this is doing is just creating a new. So now that we understand that, I want to actually move into creating our own objects and our own classes. So let's go ahead and do that. So the first thing that I want to do is kind of state a problem and then show you how we're going to solve that with OOP. So imagine I wanted to create or store information about, say, 10, 15, 20 people. I wanted to have some database, or I wanted to, at least in my program's memory, store information about a bunch of people. In Python, without understanding object-oriented programming, how might we go about doing that? Let's say I want to store the name, the age, and maybe something like the birth date of all of these people. Well, a really, I don't know, let's say naive approach might do something like this. So P1 underscore name equals, and then maybe we do Tim. Maybe we have P1 underscore age. We make that 20. And then say that's all we wanted to store. Now we have P2 underscore name, and we make that equal to Bob, and then P2 underscore age, and we make that equal to what, 43. And we continue this until we have as many people as we want, right? And then we have two variables. Each variable represents either the name or the age for a person. Obviously, not very efficient. Now, what if I tell you, hey, actually, I want 25 million people? Well, it's not realistic. You're not going to be able to do this, make that many variables, keep track of the names, so on and so forth. So some of you might have suggested, well, that's not a very good approach. Why don't we do something like this? We have a list for all of the names. We have a list for all of the ages. And then inside of names, we put Tim. Inside of age, we put 20. And, well, the indexes of the list will correspond with the same person. Great, that works, but there still is problems with this. What happens now if I have, say, I don't know, Bill, and then I have 40? Well, if I decide to delete Tim, or I decide to delete ages, now all of a sudden the index as source Bill is going to change. It's going to be hard to keep track of. I have to index the same thing in both of these lists. Really, it's just not a great solution. You could do another solution where you use something like a dictionary, but the idea here is that this just isn't the best way for me to store information about something, or yeah, that has like multiple fields, right? Like name, age, birthday, so on and so forth. It's not the best idea to do something where we're associating items simply by their index. So here comes the solution. This is OOP. So what I'm going to show you now is a class that will allow us to store an age and a name for all of our people. So I'm going to make a custom class. This is called person. I'll get into the syntax after, but just follow along for right now. And what I'm going to do inside of here is just define a class that can keep track of the name and the age of a person. So this is what's called the constructor method inside of here. I'm going to say self.age equals age and self.name equals name. And just to keep it consistent, we will put the name up here. All right, so we have self.name equals name and self.age equals age. Now, if you've never seen this before, you're probably really confused, but I'm just going to do the full example, then I'll explain the syntax. I'm going to say P1 equals person, and inside of here, I'm going to put Tim, and I'm going to put 20. Now, what I actually just did with this example, and again, I'll get into the syntax in a second, is I created a custom class. So a custom class that allows me to now create a new person object that has the name of Tim and the age of 20. Now, if I want to make another person, all I have to do is simply duplicate this line. I can do something like P2 equals person. I can change the name and I can change the age. And all of these people will behave the same. All of these people will have the same attributes, so the name and the age. And I don't have to worry about storing things in indexes. It just makes it really nice, clean, and easy. I could technically have a list of persons, so on and so forth. So now, let's actually get into the syntax of this and discuss how this works. So what I did is I defined my person class. when you create your own custom classes, you start with the class, like the actual name class here, this text class. Then you make a name for your class, and the casing or the style in which you should write this name is in what's known as Pascal case. So that means you have capitals for each of the letters, even on the first letter, right? If you're doing something like camel case, then that would be hello world. Pascal case, in contrast, would be hello world, like that. So anyways, you put a Pascal case name. In this case, I'm going to put person. If I had some other name, I would just add that on. And then you usually define what's known as the constructor for this class. So this is a method, and this actually has 2 underscores. So define underscore underscore init underscore underscore. It always takes this mandatory first argument, which is called self. And then you can add anything else in here that you want to be passed to your object when you construct it. So this is hard to describe if you've never seen OOP before, but what this method does, or how it works, is it will be called automatically whenever we create a new person object. This is what's known as our constructor. So just like when I had something like x equals list, this is constructing a new list. And on the list class, there would be this init method in the same structure that would just not take any mandatory parameters. It would take optional parameters, for example, and then it would construct the list based on what we gave it. So that's why when we printed the X to start, we got an empty list, because that was the default list construction. When I passed in, say, a string, or I passed in another list, by default, we actually got a list that had all of those elements in it. That would have been the constructor that was taking care of that and pretty much creating the object for us. So just keep in mind that whenever we create a new person object, or a new object at all, for that matter, when we have an init, then what it does is it runs this method. Now let's just talk about what all these things are in here. I need to go through them slowly. So this first argument is self. Now, what does self mean? Self pretty much is referring to the instance itself. So I know I'm using a lot of big words here, but whenever we have an object that is of a class, we call that an instance. Now, of course, we can have multiple instances of a person class, just like we can have multiple instances of an int, a string, so on and so forth. So we need to be able to differentiate and tell the difference between our instances. I don't want to be changing the name of a different person instance. I want to change the name of whatever instance I'm just about to create. So what self really stores is the instance itself. It's talking about the actual object that this constructor is being called on, or this method's being called on. So you can kind of imagine it being like the variable p1. It's not really that, but imagine that when I call this, by default, Python is going to pass to the self parameter the actual instance itself, which will be like p1, for example, versus if we had a p2 here. So let me just go Bob, and we'll go 23. So when I say self.name, I'm pretty much saying p1.name is equal to whatever name I pass in as, in this case, the second argument, which will be 10. And then I say p1.age equals, and then whatever age that I passed into this constructor. So these arguments here are matching up with the 2 things I've passed here, whereas self is just kind of implicitly being passed to the init method. We don't have to explicitly send it in. So just to show you this, I'm going to print inside of this method. Notice I have no other print statements in this program. I ran, okay? And if I run this, what's the problem here? Name, well, it would help if I spelled person correctly. And notice that I get I ran happening twice, coming out twice. So it just shows us that this init method, even though we haven't specifically called it, we don't see init anywhere other than here, is called whenever we see a statement that looks like this. Now, I will show you quickly how we can access the attributes of P1 and P2 outside of the class. And there's a lot to talk about here, so I kind of have to go back and forth. But if I do something like print P1.name, and then I print P2.name, you can take a guess at what that's going to be, but we get Tim and we get Bob. So the idea here is that when we have this class, we can have multiple instances of it that all have the same attribute names, but they may have different values, right? An attribute is simply one of these self dot something equals something else. We call that an attribute of the class, or an attribute of the instance. So an attribute of the person class would be name, another attribute would be age. So hopefully that makes sense, but this is how we would actually access these attributes. We can simply just call whatever the instance is, and then .name, like up here, we're calling self.name. Again, whatever the instance is, .name, you can think of that like p1.name. Okay, so now I'm going to show you how we actually add other methods to this class. So remember on the string class, we had something like, I don't know, us.upper, whatever it may be. How do we actually make our own methods that we can use on our instances of this person class? Well, first of all, what is a method? A method is just a function. What am I doing here? A method is simply a function that belongs to a class. And sorry, guys, my autocomplete's going crazy. I'm not able to explain when that's happening. Okay, so a method is a function that belongs to a class. Now, there's all different kinds of methods that we can have. We can have static methods, we can have class methods, but the methods we're going to be talking about here are just instance methods, otherwise known as your default standard methods. So the first thing I'm going to do here is just say define say. Now, what this method is going to do is it's going to take self, it's going to take the instance, and it's also going to take a string. And all it's going to do is it's going to print out inside of here self.name and then comma said and then comma string. So we're pretty much putting the person's name. So in this case, Tim said, and then whatever the string was. And we can add a colon there so that looks nice. Now, how do we use this method? Well, this method takes a self, right? So we need to use it on an instance of the person class. So what I'm going to do is simply go down here and say p1.say, and I'll simply put hello like that. Now, if I run this, we can see Tim said hello. So we called this method, we implicitly passed in the instance p1, and then we took p1's name, we wrote said, and then we wrote the string, and boom, there we go, we printed it out. So this is an example of a method. That's how you define one. Super simple. Always takes this self argument to start if it is an instance method. We'll talk about other methods later on. Now, just to note, the convention or the casing that you want to use when you write a method is a snake case. You want to say something like say this, like that would be the proper way to write this method. You don't use the Pascal case like you would for the class name. All right, so now that we have that, let me show you what p2.say is going to do. So we can say p2.say, and we'll just say yes. And there we go. Bob said yes. Awesome. So hopefully that's making sense, but that is how we write a method, and that's how we would use a method on our instances. Notice we can pass arguments or we can pass parameters through to our methods, just like you would do in a regular Python function, except these methods can only be used on an instance of the class. Now, just to show you something cool, I want to show you what happens if I try to use this method, but I don't use it on an instance of my class. So if I do something like person, like that, and then I say .say, and I go ahead and I pass in hello, notice that I'm referencing the person class, I'm referencing the say method, and I'm just passing in hello, which really we would assume would come in as the string. Let's just see what happens. We can see we get an error. What does it say? Say missing one required positional argument string. So what's happening here is since we don't have an instance of the class that we're calling this method on, we're going to actually be passing in hello as the self parameter. So there's two parameters here in the say method. Usually when we call this on an instance, self is already passed in for us as that instance. But since we don't have an instance, we're just calling it on the class. Hello is going to be equal to self, or self is going to be equal to hello. And then string isn't equal to anything. So we need to pass something for string. So what I will show you is how we could actually get this to work. I can pass an instance, which is P1. P1 is an instance of person, then the string, and notice that we get what we would expect. Tim said hello. So really doing person.say P1 hello is equivalent to doing P1.say and then hello like that. And of course, as we can see, we get the same thing. So hopefully that makes sense on instances, on methods. Now I'll just show you a few other methods, and I'll show you how we can actually modify the attributes of our person class. So first of all, what I will do is I'll say p1.name is equal to, not that, we'll go Joey, and then we'll print p1.name. So if we do that, we can see that successfully changes p1.name. So we can actually change these attributes by simply writing whatever the instance is, the attribute name, and then is equal to whatever we want to set it to. So that will actually set the attribute. Now, if you've ever used any other programming languages before, you've probably heard of something called getters and setters. It's typically not a good idea for us to explicitly set the attributes of a Python object without using a getter or setter and just doing it by the attribute name like this outside of the class. Usually you want any modifications to the instance itself to be happening within the class, and you can call a method or do something like that to actually, I don't know, change that. Now, in other programming languages, say like Java, you may have methods like, get name or get age. And what those methods will do is simply return to you the value of variables or attributes of your class. So for example, in Java, we would probably have implemented something like get name. We'll take a self, and then all we would do is say return self.name. So now I could do something like p1.get_name. We could print that out like this, and then we would get what we expect. We would get Tim. Now in Python, there's a cool way to implement these getters and setters that avoid us from having to call them like this. And this is what's known as the property function. Yeah, I believe it's the property function. I'm just going to show you how that works. So first of all, the reason why you would want to implement a getter or a setter is because you want something specific to happen when you're retrieving an attribute or you're updating an attribute or setting the attribute, right? Hence the name set. For example, let's say I don't want to have any people with a name that is one character or less. So obviously they have to have at least one character in their name, or they have to have, let's just go with 2 characters. Well, there's no way for me to enforce that if I simply let people do something like, P1 name equals, and then they set it to something like that, right? I can't really enforce that this name is never going to be less than 1 character or 1 character if I don't have a proper method that takes in the value, checks it, and then will only perform the update if it meets the criteria. So that's where we would use something like a getter and setter when we want to make sure that the input we're getting or that we're returning is valid. So we're not having some crash, say, if we try to return a none value, whatever it may be. That's when we would use a getter or setter. So I'm going to define my get name. I'll leave it like that. But now what I'm going to do, and actually, you know what? Forget name. I'm going to get name dot capitalize. So now whenever we get a name, we will simply take the name and we will capitalize it so that it looks obviously properly like a name. Now I'm going to define a setter. I'm going to say define set underscore name. And here it's going to take self and it's going to take a name. Now what I'll do in here is I'll make sure that the name that's being passed in is at least 1 character in length, or sorry, that is more than 1 character in length. I keep messing that up. So first we'll say if the len of name is greater than, let's go with 1, then we'll go ahead and say self.name is equal to name. So we'll update that instance's name. Otherwise, we'll raise an error and we'll just say name too short like that. And that's all we really need to do inside of this setter. Now I'll show you what happens if we try to use set name. So we will print p1.getName, but now we also print p1.set underscore name like that. And inside of here, I'm just going to pass something that's 1 character. So A. When I do that, notice that we get an error and it says name error is not defined. Oh, well, I would probably have to import that, I think. Or sorry, not error. Exception. That's what I want to use. But now if I do that, we get name exception is okay. Exception. I think I just need to spell things correctly here. Is that correct now? Exception is not defined. You know what? We're just going to leave that for now. But anyways, the point is I'm trying to raise an error. I think I'm just spelling it wrong, but anyways. Okay. So we're trying to raise an exception, one that doesn't happen, but we can just say pass and maybe then we won't change the name. But anyways, you can see that what it does is it simply, if I don't print this out, let's run this again. Let's start again. So I try to set the name to something that is 1 character. Then it just doesn't set it because, well, it's not valid. We just pass through. And then when I get the name, we get Tim back. Now, though, if I try to change it to Tim, boom, we get Tim. If I try to change it to Tim again, we get Tim. Awesome. So that's how get name and set name work. But I don't really want to have to call these methods for these things to be enforced on my class. So this is where we use something which is called property. What I can actually do down here is I can say that, what is this called? Name is equal to, and then property, which is a built-in function in Python. And I can simply write the names of my getter and my setter. So I can say get name and set name. Now, what this is saying essentially is that, okay, this name is equal to a property. The property is kind of interchangeable with attribute for an instance or for something that is one of our classes. And this means whenever I say something like p1.name, if I am getting that name, this will automatically check for that. Then it will call get name and it will give me that return value. If I am setting name, so I have the equal sign here, I'm assigning it, then it will call set name. Now, the only thing we have to do here to make this work without an error is we need to make sure that the name of this and the name of our actual attribute here is different. Now, to fix this, what I usually do is I just say self dot, oops, that's not what I meant to do. I say self dot underscore name, and then I'll just change all of the names here to be underscore name. You'll see why in a minute why we have to do that. But the reason for that essentially is that if we don't do this, then whenever I try to set the name again, it will just keep calling set name. The reason for that being that when I call p1.name, that is calling the set name. So then if I call name again inside of here and I don't use a different name, it will use the property again, and it will use it and use it and use it, and we'll get what's known as a recursion error. Anyways, I'll show you how this works now. If I do p1.name and I set this equal to hello, we can see that that does indeed work. But if I do try to set it to something like H, then no, we get whatever the name was, which was Tim. Now I can stop setting the name, and you can see that this just is working. Now inside of here, to prove this to you more, I will print a statement. So I'll say get name. And then here, when we actually say p1.name, notice that it prints get name. So hopefully that's all making sense. But that is how we use the property. And that is definitely very useful to use, especially if you want to have your users avoiding using the actual .set name or .get name, or you just don't want to have to call those methods. All right, so now that we've talked about that, we have a decent idea of how classes work. But I want to get into a better example that actually uses something you're all going to be familiar with, which is hackathon teams. So we have this person class, but now I want to show you how we can actually write multiple classes that interact with each other and have relationships between each other, because that's often what we do with object-oriented programming. So I'm going to make another class here, and my goal for this kind of mini program we're writing is to allow there to be teams, so hackathon teams, just like you guys would be in, and then have multiple people associated with those teams, so be members of those teams. One person will be the team captain. We'll need to store that somewhere, and we'll just have to figure out how we can actually store, say, persons or person objects inside of our team. So I'm going to define a class, and I'm going to call this team. And this will be good practice as well to go through the stuff I already talked about. The first thing we're going to do is define an init method. So define a constructor. So inside of here, I have to ask myself, what information do I want when I create a new team? Now, you might say, well, I want the members, I want the team captain, I want the name, so on and so forth. For our purposes, I'm simply going to say that all we need to create a new team is a name, and we need the captain. Or let's just go with leader of the team. All right. So init, self, name, and then leader. So what I'm going to do inside of here is pretty standard. We're going to say self.name equals name, and then self.leader equals lead. So now that we have that, we have a team, we can create a team, and we can set a leader. Now, what I'm going to be expecting for the leader is that we actually pass in one of these person objects. Okay, so this team is also going to store, and I'm going to define this inside of the init, a bunch of members. And inside of members, I'm going to start by putting leader. So pretty much what I'm saying here is I want to have person objects that I store in this list. So self.members is going to be equal to a list. And by default, it's going to have the team captain or the team leader in that list. You'll see how this works as we go through, but just note that what I did here is I defined an attribute that is not equal to one of the passed in arguments. And quite often we do that. We want to have some things that are properties or attributes of all of our different instances, but we don't need to explicitly pass them in. For example, if we want to have a team, like say we're looking at Pokemon, for example, which is actually an example I'm going to do next. All of those Pokemon are either dead or alive, right? I don't need to pass in by default whether it's dead or alive. We're just going to assume it's alive, and we'll have some property on there that says, self.alive equals true, right? That's an example of something you would just store on here that doesn't need to be passed through. Just like this members list, we don't need to pass through the members because we know that by default, it's just going to be the team leader, so we can create it right there. Anyways, now that we have that, I want to make a method that returns to us who the team leader is. So I want to say define get underscore team underscore leader. Here, this will take self. And all we'll do is return self.leader like that. Now, there's a few other things I need on my team. I need a way to add members to the team. I need a way to remove members from the team. Maybe I want to get the team name, whatever. There's things that I need to do. And the first thing I need to do is add members to the team. So I'm going to say define add underscore member. And inside of here, we're going to take self like we always do, and then we are going to take the member. We're going to assume that the member is a actual person object. And what we're going to do is say self.append, and we will add that member. But what we should do before we append that member is make sure that that member is not already on the team, right? So I'm going to say if not member in team, then we can go ahead and add that to the team. Lastly, we will now add something that will remove a member. So we'll say define remove underscore member, take self, and we'll take a member. And then what we'll do is we'll say if member in team, then member, no, not member, sorry. self.members dot remove, and we will remove the member. Now I just realized I'm typing team for some reason. This should be self.members. I'm sure you guys probably caught that for me because yeah, we need to access this list. All right, so hopefully that is clear. We're making sure the member is in self.members. If it is, we'll simply remove them. Otherwise, we will add them in. Now, I want to add one more method here just to show you why we even would say use a team and use the person objects. I want there to be a method that prints out all of the names of the team members. So what I'm going to do inside of here is say define print team underscore names like that. We're going to take self, and all we're going to do is say for member in self.members, and then we'll go ahead and print, you can probably guess it, member.name. Because remember, this list is going to store a bunch of member objects. So now let's actually go ahead and create a team. So I'm going to say team1 equals a team like that. And by default, what do we need to pass? Well, we need to pass a name and we need to pass a leader. So that means we need to first create the leader. So I'm just going to say team underscore lead equals, and then we'll create a new person. Of course, this person is going to be named Tim, and they're going to be 20 years old. So now we'll pass that in. So we'll pass in team lead. And just to make sure that some of this is working, we'll say define, and we don't actually need to print, but we can say team1 dot print teams, print team names like that. All right, so let's run this. And what is the issue here? Missing one required. Oh, I forgot to add in the name. Let's just make this name hackathon like that and run. Okay, so there we go. Now when we print the team names, we get Tim. So let's now try to add some members to this team and see how that works. So let's just make Bob equal to person. Go here, Bob 43. And now what we're going to do is we'll print the team names and then we'll add a team member and then we'll print them again. So say not Bob, but we'll say team1 dot add underscore member, add in Bob, and then we will team1 dot print team names like that. So now you can see we get Tim, and then it stops, and then we get Tim, and then we get Bob because we added him to the team. So hopefully that makes sense, but that's an example of how we can use classes together to interact with each other. So just to recap here, we created a team. We said that we're going to take in a name, we're going to take a leader, and then what we did is we stored the leader, and we also stored a list of all of the members, starting with just the leader inside of there. And then we have a method that gives us the team leader. We're able to add a member, remove a member, then we can print all of the team names. Now, of course, these are just toy examples. If you're actually writing real Python object-oriented code, you probably would have more detailed classes that actually make more sense than this. But I'm just trying to show you how this works in enough time that is reasonable. So now that we've talked about that, I hope you guys have a decent grasp of object-oriented programming. And I'm seeing that I have a question here. I'm not sure how long. Oh, it looks like it just came in. So let me go ahead and read this. Someone has asked, could we use a hash set instead of an array since take one time? Yes. Okay, so someone asked me, hey, can we use a set instead of an array? Absolutely correct. We can go ahead and just put a set like this. I was just using an array because I assumed most of you were familiar with that. But if I were to use a hash set, what he's saying is, hey, it's going to be a lot faster for me to retrieve, add, and remove elements to the set than it would be to use an array. So it does make more sense to use a set. So yeah, in here, I would just have to change this to be add. I think I could leave remove, and then everything else would still work fine. As we see, we get no error. So yes, definitely, you can use a hash set. Great question. All right, so now that we have that, I'm going to go into static methods and class methods. So I'll leave all the team stuff here, but I'll just get rid of the instantiations because we don't need those. And I want to go to person here, and I want to talk about something called class methods and class attributes. Well, actually, we'll start with class attributes. So let's say I want to actually keep track of how many people have been created. So I want to know how many persons or people we actually have. Well, I can't really store a counter inside of the init, right? I can't say something like self.people equals and then 0 and then add 1 to it every time we add one. The reason I can't do that is because, well, this belongs to the instance, right? So if I said something like self.people equals 1, then every single person instance would have that same attribute equal to 1. And if I added 1 to one instance, well, it's not going to change the other instances. So we need something that can actually be kept track of by the class and not by the instances. So I'm just going to have a sip of water and then we will continue. So what I'm going to do, instead of adding it as a self dot, I'm actually going to go outside of the method, so the init method and any of the other methods, and I'm going to define a field at the top of the class called num underscore people, and I'm going to set that equal to start 0. Now, what this is actually going to do for me is be a variable that is accessed by the class, not by an instance of the class. So that pretty much means that this will change for every single instance, not each individual instance. Now, what I'm going to do inside of the init method, and this will come together after the example is done, so I'm going to say person.num underscore people plus equals 1. Now, the reason I'm using person and not self is because I could use self actually. We're not going to do that because that will be too confusing. The reason I'm using person is because I want to access this class variable that belongs to the class, not the instance. So I access it with person, just like I accessed, say previously. And then I add 1 to it, and I modify that variable. This will actually change this for all of my person objects. So to prove that to you, let's create some people. I'm going to say p1 equals person. Let's just make this person named A. They can be 1. P2 equals person. They can be named B. And then can you guess what this is going to be? It's going to be 2. So now what I'm going to do is simply print out like this person.num underscore people. And I'll just print it twice, and I'll show you how it increments and goes up. So let's run this, and we can see if we expand the console that we get 1, and then we get 2. Now, just to show you something crazy, I can also print p1.numPeople and p2.numPeople. And when I run this, notice that both of them have the same value. So this will hold across all of the objects. And even though it does make more sense to access it using the class name, technically you can access it using the instance name as well. Why you would want to do that, I don't know. That just seems a little bit confusing, but you can do that because since the instance belongs to the class, it is able to access these values. So for example, say you want to define some constant that you were going to use inside of these methods, then maybe you would do something like, I don't know, let's say you had a physics engine or something. Maybe you define gravity, make that equal to negative 9.8. Then you would be able to access self.gravity from inside of here, but gravity would be the same for every single one of your instances. Hopefully that's making sense. Ask any questions, please, if that doesn't, but that is a class variable. Now, let's talk about a class method. So inside of here, I'm going to define a method. And actually, let's go back to what we had before. This class method will simply just give us the number of people. So come on, num people equals 0. All right. And let's define a method. I'm going to say define get num people like that. And the way that I make this a class method is I simply at the top of it write what's known as a decorator, which I'm not going to get into. That's beyond the scope of this. That pretty much just makes this method here a class method. Now, rather than taking in a self, what I'm going to do is I'm actually going to take in a class. Now, this is kind of seems strange. I could technically call this self if I wanted to, but CLS is kind of the short form for class. And we'll just take in a class. And what that will do is pretty much take in the person class, not an instance. So I won't be able to access anything that has that is an attribute of the instance. I can't access underscore name. I can't access age because we don't have access to an instance here. We're calling this on the class. We're not calling it on an instance. But what I can do is access any class variables or other class methods. So I could return numPeople, which is what I'm going to do. I'm going to return cls.numPeople. Now I have another question, so let me just read that quickly. Love the workshop so far. Quick time check. There's 10 minutes remaining. Oh, we're getting close to the end. Okay, I did not realize how close we were to the end. So let me speed through this, and then I'll show you guys some cool random stuff to end. Thank you for the time check, whoever that was. Okay, so this is a class method, and all this means is that we can only access anything on the class. Now I got to go fast here. But let's now, rather than printing person.numPeople, let's print person.get underscore num underscore people, and just show you that this does indeed work the same way. We get 1, 2. But if I tried to access a self attribute, that wouldn't work inside of here. Okay. Last thing we have is what's known as static methods. So if I have at static method, this is the decorator that we use. Then we define something like, say, add underscore nums. This makes no sense to have in people, but just as a quick example, inside of here, we do not need to take a class and we do not need to take an instance. instance, because inside of a static method, any other methods other than static methods from this class. So what I could do in here is do something like return and then x plus y. And well, that would be what this static method does. Why would you have a static method? Let's say you had a math module and you had a class that you wanted to store all of your trigonomic functions. Well, you would say class trigonomic functions. Then you could define a bunch of static methods that did not require an instance to actually operate on. Anyways, that was static methods and class methods. I went through that pretty fast because I'm trying to show you guys some cool stuff before we end off. Now, I just want to talk to you about something that you're probably not going to remember, but that is just really cool and that I've only really seen you can do in Python, at least as effectively as this. So just notice that when we have a list, I have something like x equals, whatever it may be, I can access items in the list by indexing them, right? And there's also these cool operations, like I can do something like y equals x plus 1, 2. Like there's all this random fancy syntax that I can use in Python. And remember I told you that everything in Python is an object, and that object defines that class that it is a type of defines the behavior that it can have. It defines the operators we can use on it. It defines the way we construct it, so on and so forth. So really, in the list class, there's actually a definition of this plus symbol that says what happens when we try to add two of these two things together. And I'm going to show you how we can actually create our own custom, what's known as operator overloads in a class. So I'm going to say class. I'm just going to call this poly. Maybe it would be like a polynomial or something. Inside of here, I'm going to say define init. And I apologize for going fast, but I want to show you guys this. I'm going to say self.x equals x. And then I'm going to define what are known as special Dunder methods in Python. So if you want to look this up afterwards, it's called Dunder methods, D-U-N-D-E-R. And they're pretty much just double underscore. That's what it stands for. So inside of here, first of all, I'm going to define the add method. Now, what this is going to allow me to do is take myself as well as some other object, and it allows me pretty much to define what happens when I try to add these objects together. Now, all I'm going to do is return self.x plus other.x, but now you'll see how this works. So if I go and I say, p equals, or I'll say p1 equals poly with a value 2, and p2 equals poly with the value 3. Now what happens if I say print p1 plus p2? Well, what do we get? We get the value 5. Now, if I remove this method like that, and I try to do this, we get a crash. It says unsupported operand for those types. So I can actually define the fact that, hey, I can add these two items together. And we can do a bunch of other cool stuff as well. I also could technically have returned a poly object. So I'll do that. I'll return the poly object. But now look, I returned a new poly object, which was equal to, which would have had the value 5 or x at 5, but it's printing out and it's looking all gibberish. So how do I fix that? Because, when I print out a list, it doesn't give me all that gibberish that it's some object and something. It gives me the list. Well, there's a method for that as well. This is called the repr method. So I can actually define __ repr, which stands for internal representation. I can put self, and then here I can return the string representation of this object. So I can actually do something like if I wanted to make an f string and then poly, and then inside of here, go ahead and put self.x. Now, watch the magic. When I run this, we get poly 5 rather than that random gibberish. So when I try to print something, it actually calls on each of the objects that I'm trying to print, or the one object in this case, because returned here will be a poly object, the repr method. And if it does have a repr method, it will use what's returned from that as the output from the print statement. So just showing you an example of some of the cool stuff that you can do in Python. You can also do define __ get item and __ set item. So if you wanted to make a collection like class or collection like item in Python, you could do that. Now, I think I'm reaching the end of the workshop here, so I'm going to stop for now and just ask if you guys have any last questions before I head off. But I would highly recommend you guys look into these Dunder methods in Python. To me, they're super fascinating and they make it really cool and really interesting to create your own objects and functionality with them. So yeah, that's pretty much it. Could you recommend some websites used to learn more about object-oriented programming? Also, could you recommend any projects which can be done in Java or Python? So for that, I'm going to say shameless plug. I have a bunch of videos on my channel about object-oriented programming. In fact, this workshop is based off of one of the popular videos on my channel. So if you go to Tech with Tim and just search object-oriented programming, you will see some tutorials there. I also have a website called techwithtim.net that goes through this stuff. But really, I don't use any other resources. I haven't had to learn object-oriented programming in a long time, so it's hard for me to give you any good examples. In terms of projects that can be done, if you're talking about using object-oriented programming, quite literally anything. It's hard for me to just spit stuff off the top of my head, but I do have a bunch of videos on my channel as well that literally go through beginner, intermediate, advanced Python projects. So you can have a look at those and hopefully they'll give you some inspiration. All right, any last questions from you guys before we head off? Just put them in the chats. But I did enjoy this workshop and I hope that you guys got some stuff out of it. Hi, Tim. How did you buy your domain for your website? Great workshop. First of all, thank you. Appreciate that. Second of all, how did I buy it? I believe I used like Domain Cheap or something, or Namecheap. That's what it's called, Namecheap. And I also just purchased the domain, and then I think you have to set up like a, what's it called? Oh, I did this so long ago. Like it's like a proxy or like a DNS or something. So it points that domain to your virtual web server or virtual private server, which is actually hosting the website. Anyways, there should be like millions of tutorials online for how to do that. So pretty straightforward. And I think the domain was like 20 bucks or something. Anything else, guys? Any last questions before we head off? No? All right. I'm not seeing any come in.
I think that's it.
Awesome.
Awesome. Thank you so much for doing this workshop.
No problem. Thank you for having me. I enjoyed it.
Sounds great. Is there any way that people who have any more questions can contact you? Do you have a preferred method of contact?
Honestly, if you just leave comments on my YouTube channel, I might get back to you. You can also try to DM me on Instagram, DM me on Twitter. I'll be honest, I get a lot of messages, so it's pretty hard for me to answer everybody, but who knows, you might get lucky. I might be scrolling through the inbox and it pops up and I answer you. So yeah, Twitter, Instagram, and YouTube comments.
Sounds good. And just one more question that just came in
Sure.
right before we end it. Someone asked, what languages do you recommend learning after doing Java, Python, and JavaScript?
Java, Python, JavaScript. Honestly, after you've learned those three languages, it's just a matter of what you like best, right? All those languages are pretty different. I would recommend learning something like Golang or learning like a more functional or imperative programming language. Just look up the different programming language paradigms and try to learn something that's different from what you already know, right? You've already learned an object-oriented programming language. Is JavaScript object-oriented? I don't think it is. But anyways, just learn something new, like something different, maybe something like a C, just to give you like a good, I don't know, background or knowledge of the different paradigms of programming languages. But I would highly recommend Golang. I really like that one, and it's really cool, and it's pretty similar to Python, but super performance heavy and related to concurrency and stuff. So that would be a good choice.